As an extension of section 3.4, which was optimization problems, meaning maximizing and minimizing, a nice, wonderful application is into business and economics. Maximizing and minimizing for business functions is absolutely huge. For instance, remember that revenue is the money that you bring in, cost is a business's expenses, and profit is the actual money that they make, that they take home, which is revenue minus cost. So let's use these. Anytime you have revenue or profit, you usually want to maximize it. Anytime you have costs, you usually want to minimize it. So let's take a look at what we have here. Example 1 says, find the number of units that must be proctored to maximize the revenue function. So it gives us our revenue function, negative x cubed plus 150x squared plus 9,375x, where r is the total revenue in dollars and x is the number of units produced and sold. It says, what is the maximum revenue? So anytime I want to find a maximum, I have a choice, the first derivative test or the second derivative test. Again, if it's an easy first derivative, I like using the second derivative test, so let's see what we have. First step is to find that derivative, r prime of x, which would be the marginal revenue function, if you remember that. Using just the straightforward power rules, you'd have negative 3x squared plus 300x plus 9,375. Again, what you want to do here is set this equal to 0. If we're setting it equal to 0, we have many different ways of solving this quadratic equation. We could just use the quadratic formula, could try factoring, whatever we want to do. What I'll do is I'll notice it looks to me like every single one of these is divisible by negative 3. So this will just make smaller numbers to plug into the quadratic formula. You didn't have to do this. This is just something I chose to do to get smaller numbers just because I noticed there was a common factor. So when I do this, I end up with x squared minus 100x. 9,375 divided by 3 is minus 3,125 equals 0. So that gives me my a is 1, my b is negative 100, my c is negative 3125. I'm going to plug it into the quadratic formula, which is negative b. So here I have x equals negative b would be a positive 100, plus or minus the square root of b squared, so negative 100 squared, minus 4 times a, which is 1, times c, which is negative 3125, all over 2a, which would be 2 times 1. I'm going to plug that in right now into my calculator. Please plug it in and simplify. Plugging it into my calculator, I'm actually getting two values. I'm getting negative 25. Negative 25, this being the number of units that I'm producing, that makes no sense. But the second number that I did get did make sense. I got 125. So it seems my only critical value that I have to check is 125. Again, to check this, I could use the first derivative test, which would be doing a sign chart on this, or I could simply use the second derivative test, which I like to do here because this is a simple polynomial function. So remember, my first derivative was negative 3x squared plus 300x plus 9375. Taking the derivative of this would be negative 6x, and it would be plus 300 plus 0. I plug in my critical value of 125. So this would be negative 6 times 125 plus 300. That number is a negative value. So again, if my second derivative is negative, that tells me that my original function is concave down. Because my original function is concave down, that means at x equals 125, I have a maximum. So what do I have to do now? All I know is that my critical value is a maximum, but I do need to actually go back in and look and see what the question asks for. So it says it wants the units. How many units should I produce? Well, x is the number of units. I know now that I should produce 125 units, but it also asked me what is my maximum revenue. So that means I need to plug in 125 into my actual revenue function. So do that now. Find r of 125. Plugging that in would be negative 125 cubed plus 150 times 125 squared. Then it's plus 9,375 times that 125. Plug that into your calculator. I'm getting $1,562,500. So that would be my maximum revenue, $1,562,500. And that ends example number 1. So let's look at the next thing here, what we're talking about. It says what we want to do is minimize average cost. We know we can't minimize cost. That doesn't necessarily make sense in business. To minimize cost, all you have to do is sit there and produce nothing. If I produce nothing, my cost should be nothing, or whatever my fixed costs are. So minimizing costs isn't quite as straightforward. What we want to do is find the average cost of a unit, and we want to minimize the average cost of a unit. So for instance, if I can pay $3 a unit or $2 a unit on average, that $2 a unit is what I want to do. So how do I minimize average cost? Well, think about making an average. To do an average, you add up the sum total of everything, then divide it by the number there are. Well, here we have the cost function, and we divide it by the number there are. The number there are is x. Okay, so how do we find the average cost function? Take the original cost function and divide it by x. That's how you find average cost. Then we're going to be minimizing the average cost. So step 1, find the average cost by dividing cost by x, then find its derivative and its critical values. So let's look at example 2 here. It says to do exactly that. Find the production level that minimizes the average cost per unit for the cost function C equals 400 plus 0.05x plus 0.0025x squared, where C is the cost in dollars of producing X units of a product. So again, the first thing we want to do here is find average cost. Average cost is the cost function divided by X. So let's do that math now. I would have C bar, which is the average cost function, is going to be 400 plus 0.05 x plus 0.0025 x squared. And then I have to divide that by x. What I'm going to do to help me simplify is instead of dividing the whole thing by x, I'm going to divide each term by x and simplify that way. So my average cost function looks like I'm going to have 400 x to the negative 1. Remember, I'm going to be taking the derivative of this. The x's simplify in the next one, so I just have plus 0.05. And then the x's simplify in the next one as well. And I'm left with plus 0.0025x. That is my average cost function. Again, I have not taken a derivative yet. I have just found the average cost function. So now I want to minimize that, so I'm going to find the derivative of the average cost function. The derivative of 400x to the negative 1 using the power rule would be negative 400x to the negative 2. The derivative of 0.05 is 0, and the derivative of 0.0025x is 0.0025. Writing this in simpler form, we'd have negative 400 over x squared plus 0.0025. If we want to get a common denominator on this one, I'll multiply the second term by x squared over x squared. So it looks like I would have negative 400 over x squared plus 0.0025 x squared all over x squared. We're combining like terms and simplifying, writing it in descending order. I'd have 0.0025 x squared minus 400 all over x squared. Again, that's just the denominators are common, so I added them, but then I wrote it in descending order. So this is my marginal average cost function. Average cost, the derivative of that. I want when is this equal to 0 and when is it undefined. This would be undefined when the denominator equals 0, which would give me x equals 0. Again, that says produces 0 units. That makes no sense. We don't care about that. So what we want is when the numerator is equal to 0, 0.0025x squared minus 400 is equal to 0. I'm going to go ahead and add 400 to both sides. When I add 400 to both sides, I end up with 0.0025x squared equals 400. I divide both sides by 0.0025. I end up with x squared equals 0.0025 divided by 400. I'm getting 160,000. I take the square roots of both sides. Again, usually I have to remember plus or minus, but negative means nothing to me here. So I get x equals, well, the square root of 160,000 is 400. So that's my critical value right there, the only critical value I have. I need to test to verify, is this a maximum or a minimum? The way that I do that is I can either use the first derivative test or the second derivative test. Well, I'm going to go back to my, well, actually this one, since it's a fraction, I might want to use that first derivative test. That's totally up to you. Actually, what I'm doing is I'm going back through and I'm looking at my work and I'm saying, look, here was the original derivative, the negative 400x to the negative 2 plus 0.0025. That's easy to find the second derivative. So if I want to find the second derivative here, the average cost function, then I'm finding the second derivative of that. It's going to be, well, negative 400 times negative 2 would be 800, and then it would be x to the negative 3. And the derivative of 0.0025 is 0, so I don't need to worry about that. So if I take the second derivative of the average cost function, and I want to plug in the number 400, this would be 800 over 400 cubed. If I move it to the denominator to make the exponent positive, which is positive. So my second derivative of the average cost is positive. Since the second derivative is positive, that means it's concave up. The original function, average cost function, is concave up, which tells me that at x equals 400, I must have a minimum. So I have indeed verified that I have a minimum average cost when x equals 400. That doesn't mean it's the answer to the problem. Let's go ahead and look and see what the problem says. It says find the production level that minimizes. So they're saying how many units should I produce? And I indeed did just verify that I need 400 units produced to minimize the average cost.